Hey everyone, welcome to the second Leetcode coding problem explanation. Today's problem is going to be data stream as disjoint intervals. So I already did the mock interview and this problem is actually pretty hard. So I spent like a whole hour, and at the end I still had a bug or like a runtime error or something like that, so I wasn't able to finish it. But that video with the mock interview will be posted at the same time as this. Check it out if you want, but it's long and I don't know what you're gonna get out of it, but it's there. So anyway, I expect that this explanation will also be pretty long. So yeah, but I think actually this problem is pretty good, and if you get stuck, this explanation will definitely hopefully help you out. So how I imagine you would do this is, first, if you haven't done this problem, you should definitely go do so. It's called data stream as disjoint intervals. Then if you have a solution and you just want to look at my solution, or just to better understand the problem, or if you got stuck and you want someone to guide you through it kind of like step by step, then watch this video. And then if you're curious about how I did when I mock interviewed this, then check out that other video. Anyway, let's get to the problem. So the problem is data stream as disjoint intervals. So basically you're given a data stream of non-negative integers, which is like 0 and all positive integers, and summarize the numbers seen so far as a list of disjoint intervals. It will make more sense with this example. So you get a data stream, right? Like you get one number at a time. The example they have is 1, 3, 7, 2, 6. So when you put in 1, you make an interval from 1 to 1. Then when they put in 3, it's interval 1, 1, 3, 3. 7, same thing, 1, 1, 3, 3, 7, 7. When there's a 2, it connects 1, 1 and 3, 3 and becomes 1 to 3. So now it's 1 to 3 and 7 to 7. And same thing with 6. 6 combines with this interval, 7 to 7, to make 6 to 7. So yeah, so basically you have to make a data structure. You set it up over here, then you add numbers to your intervals, and then get intervals returns those intervals. So first of all, when I approach a problem, I think about how would I do this by hand. My general process is I sort of think about some test cases, or just try to do it by hand, and then afterwards, after I do that for a while, or for like maybe 30 seconds, I try to figure out some sort of pattern that I can then generate some pseudocode for, and basically an algorithm. And after I have some idea of that pseudocode or algorithm, then I just code and do the rest of the thinking as I code. So so first of all, how would I do this by hand? How would you do this by hand? What are some of the edge cases or test cases? I'll give you, let's say, I'll give you 2 to start off. So one of them is there are no intervals. And then another one is if val is 1 away from the end of an interval. So let's say that the intervals are like 1 to 2 and then 5 to 8, right? If your value is 9, then 9 is 1 away from the end of this interval, right? So I'll give you 5 seconds, but you should definitely pause the video and come up with your own edge cases. Go. Okay, so did you come up with some test cases? So the ones I came up with were, in addition to these two, first of all, there are no intervals, and then another case is there are intervals and val is in one of the intervals. So if it was like I'll just use the one I already gave, 5 to 8. What if val is 7, right? Since val is 7, it's between 5 and 8, so val is in one of these intervals. Then we have if val is 1 away from the end of an interval. Well, what if val is more than 1 away from the end of the interval? Like this, right? Then similarly, if val is 1 away from the beginning of an interval, so something like 4. So, well, I could say the start. So 4 is 1 away from 5 to 8, right? Then, as you might guess, if val is more than 1 away from the start of an interval. So this is a bad example, but let's say this was 15 to 18 and val was 10. And as you can see here, there might be some overlap between this rule and this rule, because the val could be more than 1 away from 15, and it could be more than 1 away from 2, or it could be more than 1 away from 15, but it could be 1 away from 2. See, so there's some overlap with these test cases. Then the 7th one is there is a smaller interval and a larger interval that are both 1 away from val. So an example of this is 1 to 2, or let's say 1 to 5, and then 7 to 10, and then your value is 6. So yeah. So these are, I guess you could say, more specific test cases, but we want to like come up with some patterns, right? We don't want to make an if and else statement for each of these test cases. So you want to, when you're trying to solve algorithms, you want to be able to notice patterns and then try to solve them. So another way of saying finding patterns is generalizing these cases. So I'll give you 5 seconds to come up with your own generalized cases. And as I mentioned just a few minutes ago, there are some overlaps. So good luck. 5 seconds, go. Okay, so did you come up with some generalized cases? How I would generalize this would be, first of all, we would want to keep that there are no intervals, and then also we want to keep that val is in one of the intervals. Now for the cases after that, you can see that if val is 1 away from the end, and then if val is 1 away from the start, then you could generalize it and say val is 1 away from an interval. Then there's if val is more than 1 away from the end of the interval, if val is more than 1 away from the start of the interval. You can say val is more than 1 away from all intervals. And then there are 2 intervals that are 1 away. So basically the same as there's a smaller interval and a larger interval. Okay, so now that you have generalized cases, how do we deal with each of these cases? I'll give you 5 seconds. Basically, if you're to do this by hand, in each of these cases, what would you do? Like if there are no intervals, you'd make an interval, right? And if val is in one of the intervals, you don't do anything. What would you do in the other 3 cases? Okay, so as I said earlier, when there are no intervals, make an interval. When val is in one of the intervals, do nothing. Now, when val is 1 away from interval, merge/modify the interval. When val is more than 1 away from all intervals, make an interval. And then when there are 2 intervals that are 1 away, combine the intervals. And looking at this, when val is more than 1 away from all intervals, you can sort of combine that with there are no intervals, right? So that's an optimization we can make later on. And yeah, so once you think of those cases, then you can start to formulate what you want your algorithm to kind of look like, and your idea of the algorithm sort of starts to take shape. So just a side note, on an actual interview, I don't think I would have the time to write all of this out, and at the same time, my thinking also wouldn't be this coherent and this logical. It'd be a lot more messy. But since this is an explanation, I'm trying to go in depth. But just keep in mind that in a real interview, you might like think of a few of these test cases, and then notice other ones later on as you go. Like maybe this one you'll sort of like derive or figure out as you code. But anyway, so these are the test cases. Now you have the test cases. It's time to think of an algorithm. The problem with these test cases is that you can't immediately translate them into code, right? So why don't I give you some time, try to write your own pseudocode, and then afterwards check back and see the pseudocode I wrote, or if you get stuck, then I'll try to help you. I'll try to guide you through the pseudocode. Go. Okay, so how'd it go? One thing to realize is that you really only need to find 2 intervals that are next to the value, one on the left and one on the right. And the thing is, we have to find them one at a time, and when we find one, we can find the other. So what I mean by this is, let's say you have a couple of intervals. Okay, so we have a couple of intervals, right? And the value, let's say, is 9 or 11. So when we look at 11, we actually don't really need to care about 1 to 5 or 33 to 35. We only care about 2 to 8 and 15 to 30. And even if we add like another one, like 50 to 51, with the value of 11, we still only care about 2 to 8 and 15 to 30, because these are ones that we will potentially, these are intervals that will potentially contain the value or be one away from the value, or or value might actually combine both of these intervals. In all of the cases, 1 to 5, 33 to 35, and 50 to 51 aren't intervals of interest. So first thing to realize is that only intervals immediately left and right of val are of interest. And the thing is, also keep in mind that left or right might not exist if you're like on the edge or values less than all the intervals. Anyway, so basically left and right matter the most, right? So it doesn't really matter. It doesn't matter which one you choose when you're solving this problem, but I like to choose always the left one, because I like to think about things from left to right. And in other words, it's finding the interval that has the largest start time less than the given value. So basically, if 11 is my value, 2 is the largest start time less than 11. So find the if you've done interview prep, this might not be something new to you, but if you're just starting out to prepare for interviews, you might ask like, how would you even know to think about this? Well, with time and practice, you should develop an intuition to figure this out pretty quickly. With intervals, especially with intervals, you almost always want to sort them, because it's like an n log n, it's an n log n operation to sort, and normally that like makes things a lot better and simpler to work with, and easier to work with, and easier to think about. So after you sort it, then you should realize that the ones that matter are just the ones on the left and the right, because those are the only ones you have to worry about modifying. So this comes with practice, and every kind of question, like tree questions, string questions, they all come with their own tricks, I guess, tricks and patterns that you sort of notice and start to implement over and over again as you keep doing these problems. Anyway, yeah, so don't worry if you're like, oh my god, how am I supposed to figure that out on an interview? Sooner or later, it's gonna all look the same to you. So yeah, anyway, so now that you know that you need the interval with the largest start time less than the value, how do you write the algorithm with this hint? You don't have to write an algorithm just yet, or write code, but just do it in pseudocode. So 5 seconds, go. Okay, so how's your pseudocode? So I'll write some myself. So first of all, we have to check if there are no intervals, then we make an interval, right? So if intervals is empty, then make new interval, insert. And sorry if my pseudocode is like really not pseudocode syntax, but whatever. Fine. The second one is value is in one of the intervals, right? So how do we figure that out? Well, as I said before, we want to find the interval with the largest start time less than the value, so the interval on the left. And after finding that, all we have to do is see if that interval's end time is greater than the value. So that might be a lot to take in. So let's say we have the interval 5 to 10 and the value is 11. So of course 11 isn't in 10, right? But if value was 8, then this interval's end time is greater than the value, meaning that 8 is in the interval. So in order to do that, first of all, we have to find let interval equal, or let's call it left interval. Left interval equal greatest start time less than val. So we're gonna have to write an algorithm for that too, but for now we'll do that, and then afterwards then we can see really easily if val is in one of the intervals. So if left interval is dot end is greater than val, then return. Okay, so we took care of number 2. Alright, let's look at number 3. So for test case number 3, val is 1 away from an interval. So let's look at left interval first, right? Since we already have it. So if left interval dot end is equal to val minus 1, then left interval dot end equal val. So we modify that, and then at this point, if we merge it in, we also have to keep in mind that by changing left interval dot end, we might connect it with the next interval. So at the very end, see if we can merge left interval with right interval. And then afterwards, if that's not the case, then we want to check right interval dot start if that's equal to val plus 1. And if it is, then right interval dot start equal to val. So that takes care of if val is 1 away from interval. Now what if val is neither of these? So val is more than 1 away from all intervals, or basically more than 1 away from the left and the right interval. In that case, then we just have to make a new interval. So make new interval and insert. Okay, and you might be saying, oh, well, what if left interval or right interval don't exist? Then we have to have checks for that. And what if you say, well, how do we find right interval? Well, if we have the index of the left interval, then right interval would just be index plus 1, right? Anyway, so this is the pseudocode. Please note that you don't have to be this detailed in your pseudocode on an actual interview. Normally I just write some pseudocode, but once I have an idea of the algorithm, I just do the rest of the thinking in code. And I think it's actually kind of detrimental if you just try to figure out the algorithm and perfect it before you write like a single line of code. And this happens to me where I just get so caught up in thinking, and the interviewer is just like, okay, I think we should just start writing some code now. And like, okay, yeah, I agree. Anyway, so this is the pseudocode. The next step is to actually code out this algorithm. So why don't I give you 5 seconds? Obviously, not really 5 seconds, but pause the video and why don't you first try to write the code yourself and maybe even get it to compile and pass all the test cases. And yeah, so go. Okay, so hopefully that wasn't too bad. Now I'll actually code this out. So first of all, we have to initialize our vector to return. And if you're not familiar with C++, a vector is kind of like an array list or like an array. Yeah, so let's see, vector of int, and let's call this intervals. And then when we get intervals, all we have to do is return intervals. Just to be safe, we'll initialize it. So there's a fresh copy. Okay, so I'm wondering if I should put the pseudocode in there. I don't see why not. Okay. So if intervals is empty, then we make a new interval. So if intervals dot size equal to 0, then we make a new interval. So how do we make a new interval? So I'm doing the inserting and making the interval on the same line. So to make a new interval, I just do this, interval val, which is the start, and val, which is the end. And then after that, I push back. So I basically push this interval into the intervals vector. After that, I just return. So that's test case number 1. Test case number 2 is I have to first of all find the left interval, right? So when you're given a sorted array, right, there's something called binary search, which lets you find an element you're looking for in log n time. But for now, I'm just going to do something very simple. I'm just going to have an index that is the size of intervals minus 1. So basically what this does is I just start on the last element, right? And then I just have a simple while loop that says while the index is greater than or equal to 0, and intervals intervals at index dot start is greater than val. Then we decrement index. Okay, so we start at the last element and we keep going left until we hit an interval whose start time is not greater than the value, which means that basically at the end of this while loop, intervals at index.start will be less than or equal to value. Or that doesn't exist and index will now equal -1. Okay, so after that we just check if val is in left interval. So yeah, in that case we just don't do anything. Okay, so now we have to check what if it's one away. Well, if it's one away, seems like my pseudocode's pretty helpful. If value is 1 away from the left interval, then we set the interval.end equal to value. Now, if the interval, if that's not the case, then we check the interval on the right. If the interval on the right's start time is equal to the value plus 1, that means that we want to modify the right interval's start time. Otherwise, we have to make a new interval. So intervals.push back, and we push back a new interval from val to val. Now, as I mentioned earlier, we have to address edge cases where the left interval doesn't exist or the right interval doesn't exist, right? So if index so we have to say index is not equal to -1 and left interval.end blah blah blah. In this case, we need index plus 1 to be less than intervals.size. Now, how do we get right interval? We just change that to be intervals at index plus 1. Okay. And then finally, at the end of this, we have to check if we want to merge the two intervals. So first of all, we have to do these checks again if the intervals even exist, if both intervals exist. So if index is not equal to -1 and index plus 1 is less than intervals.size, then we have to check and intervals at index dot end. So how do we check if we want to merge them? Well, the end and the start have to be the same. So we do intervals at index.end equal to intervals at index plus 1 dot start. And then in this case, if that's true, then we want to merge them, right? So intervals at index.end will equal intervals intervals at index plus 1 dot end, right? So we now set the end. So if we want to merge 2 to 5 and 6 to 10, we want to just take the end of the second right interval and put it into the end of the first interval. So now we make this 2 to 10. That's basically what it does. After that, we have to erase the interval. So intervals.erase, and this is C++ syntax, so intervals.begin plus index plus 1. And all this does is basically erase the element at index plus 1, which is right interval. And that should be the code. Let's try running this and hopefully it works. 79. Okay, so actually, I made a mistake. This should be a vector of intervals, not a vector of ints. So that confused me. Left interval is not declared in the scope, of course. So, yeah. Oh my gosh, there's so many. 92. Forgot my semicolon. Too much Swift programming. 95. Okay, yeah, maybe it's not a good idea to directly use pseudocode. Okay, so there's actually a bug in my code. This is the output, and this is the expected output. Now, after you see what went wrong here, why don't you look at my code, and why don't you tell me where's the bug in my code? I'll give you 5 seconds. Okay, so did you find it? So let's first go through the output. Everything is good when I put in a 1, a 3, and a 7. When I put in a 2, it successfully merged with the 1, 1 interval, but afterwards it was supposed to merge it into the 3, 3 interval too, right? It was supposed to combine them. But how come the code didn't really combine the 1 and the 2 and the 3 and the 3? Everything up to here is fine, but then when you look at the left interval.end, so 2, and then the right interval.start, 3, I'm expecting them to be equal before combining. But actually, what I actually need is the start intervals.end equal to the right intervals, so the left intervals.end equal to the right intervals.start minus 1. And that will effectively combine the two intervals. Okay, and now I have another error. And what's happening this time? Well, I put in a 6, and when I put in another 6, it adds it in. Wonder why that is. Can you figure it out? I'll give you 5 seconds, but it should be pretty easy, right? Okay, so did you find it? So right now we're checking if val is less than the interval's end. But what if it's equal? If val is equal to the end, it's still in the interval. So you have to add that. In addition, I also have to check if the left interval even exists. So that's something I didn't check before. Okay, so now that we fixed that, there's still one more bug over here. Now, I'm not expecting you to find it, but if you're up for the challenge, then go ahead. I'll give you 5 more seconds. This is the final bug. Okay, so looking at my code, I still see one more bug, and I think it's the final bug. It's kind of tricky, but if you're up for the challenge, I'll give you 5 more seconds to try to find it. Otherwise, just wait 5 seconds with me, and I'll let you know what it is. Go. Okay, so did you find it? So right now on line 100, I'm making a new interval and I'm putting it at the back of intervals. What I want to do is I want to insert it between left and right interval. So what I should have done was intervals.insert intervals.begin at index plus 1, and I want to put in there interval val from val to val. So instead of, so it's, if I had some intervals instead, and then let's say the value is let's say the value is 0. Instead of putting 0, 0 at the end over here, I want to put it over here at index 0. Okay, so hopefully this is the final bug and I'll get that green money. I mean, that's not, yeah. Okay, awesome. So let's do some runtime analysis of this. Right now, getting intervals is just O of 1, it's constant time. The main work is done in adding the number, right? So if we go through this step by step, this is, I guess, O of 1. Now, when we find the interval with the greatest start time less than or equal to value, we just potentially go through the whole intervals, right? So this would be runtime of O of n. Then these operations are constant time, but when we insert, this is another O of n operation. And then over here, we're modifying and then we're erasing. This could be another O of n operation. So basically, overall, this is O of 3n, which turns to O of n. Now, after runtime analysis, we have to ask, well, are there any optimizations that we can make? And there are. So first of all, we can use, as I said earlier, binary search to find the interval with the greatest start time less than or equal to value. I think binary search is a really valuable algorithm to learn, and there's a really good top-coded tutorial on that. So this could be O of log n, reduced to that. But when it comes to inserting and deleting elements in an array, those are just O of n operations. So if we want to use an array or a vector, it has to be, these operations will cost O of n. Now, as you can see in the mock interview video, I did think about using, I think I said a heap, but thinking about it more, we could use a rebalancing binary search tree so that finding an element costs log n, and then inserting an element costs log n, and then also deleting an element costs log n. So definitely you could try to implement this using a rebalancing binary search tree. So to wrap this up, what is the tricky part about this problem? As you can see, like, even though I prepared for this question a little bit more before explaining it, I still ran into some like edge case scenarios. So definitely keeping track of all the edge cases and figuring out how to solve them is the tricky part for this problem. Yeah, and that's the tricky part. If you don't want to watch the whole mock interview video, I think you can skip to the end. I kind of talked about how luck is sort of involved in these questions. Again, I keep talking about that, but at the end of the day, if you get a question like this, you just have to try your best. And the more important thing is you want to prepare before your interview as much as possible, so that you either get super lucky and get a good question, or you get a hard question but you're at least prepared enough to tackle that problem head on. Anyway, thank you for watching through this whole video. I know it was really long. Let me know if this helped you. Let me know if there's any feedback you can give me. If there's anything you want me to do or stop doing. If there's anything you want me to do better. Maybe if I should like have a working solution so that no bugs appear, or if you actually really enjoyed looking at that bug and figuring out what went wrong in my code. But yeah, thank you. Until next time, have a great day.